Okay, so I invented a file format. It's a text file format that can be really, really big. Let's say you have millions of entries, like these Wikipedia-like entries here, and you just put them in a text file and put little indices here, 1, 2, whatever, and you also make a list in the beginning, linking the word frog to index 1, dog to index 2. And if you use this specific format here, which I invented, the fluid text file format, then the computer can optimize it. Let's say we save this as animals.fluid. .fluid is a nice file extension, isn't it? And we run this file through the optimizer or cleaner. It's called clean fluid text file. Then it will make a backup of the file. And it changes the original file. And now it has changed slightly. Every item now has a length, which is just the length in bytes of this content. And every entry has a number, but the number now is the exact byte index in the file. So what used to be 1 and 2 is now 4, 9, and E2, which are hexadecimal byte offsets. And the first entry has the index 0, because it starts at byte 0. And now this file is super optimized for a computer. The computer can go through the index, find the word it's looking for, and the byte position, and jump to this byte position in the file, no matter how big the file is, instantly. So this is great for actually making a database on disk. And the other trick is that I can still open this file in a text editor, if the editor can handle big files, obviously. And I can change something, and then I run this cleaner program again, and it will fix all the indices. For example, I make something new. Item 3, a giraffe is a big animal. And I say giraffe at 3. Now it's not a clean fluid text file anymore, because this index here is not the byte index anymore. So as is, it cannot be used for efficient lookups anymore. But if the computer knows that, it just knows it has to optimize this file again. So let's do that. It has changed. By the way, if you do it again, it will notice that nothing changes, indicated by the false here, and there is no reload button here. So now it has done the optimization again. All the byte indices have changed, and they are correct with respect to the index. So this is an optimized database again. So that's the kind of file format I want. Readable by humans, editable by humans, and usable by computers, and very efficient. There is very little unnecessary overhead here. There's a bit of text formatting going on for these headers, but this is almost as efficient as a byte format. I really don't like these byte formats that you can't look at in a text editor. I think the gain in efficiency is not worth losing this easy access to the file. So, and one more trick you can do is mark a whole entry as not necessary. If this length flag is changed to an underscore and you drop the references, then this whole entry will be just deleted. Let's try. Yes, it's deleted. So this is for live databases where you take out entries, but you don't want to rewrite the whole file. You just mark the entry as I just showed. And whenever there's time, the computer will go through the file and compact the whole file. Basically make a copy of it in a new file without the deleted entries. So because right now I have my AI databases in memory. If I have any database that is bigger than what you want to hold in main memory, My infrastructure doesn't support that all too well. But with this kind of file format, it's totally possible. With this, you can have on-disk databases that are huge, lots of text, and still work with it efficiently. Because we want to store many facts and many rules in our AI, obviously.